In example 4, we're asked to evaluate the following limits. We're going to do these with our graphing calculator. First of all, you can see here that as x approaches 0, would not work if we just went ahead and simply just tried to use direct substitution here, because this function actually does not exist at an x value of 0, so it's discontinuous. However, we can type this into the calculator, and we could use -4. Let's go, there's the sine of x, and we'll divide that by x. Keep in mind you want to be in radian mode, so check your calculator and make sure you're in radian mode, and then you can hit graph. And you see this is a wonderful function that kind of gets a little bit wavy, and we can try to see what's happening as we get close to 0. So one thing I like to do is just look at the graph first and look at it and say, well, it looks like this thing is, from the left, it's getting close to -4, and from the right, it's also getting close to -4. Doesn't mean that it actually goes to -4. It might be -4.1 or -4.2. So looking at a graph is a really good idea to find what value it might get close to. But let's try to get a little bit more precise. If we take a look at our table, first go to the table set, and in this case, I've got it set on some end behavior stuff here, so we're going to take a look at 0. And when we're taking a look at a finite number, like 0 or -5 or 6, as opposed to infinity or negative infinity, you're going to just type a 0 in for your table start, or whatever value you're looking at. In this case, it's 0. And then our delta table will be pretty small. I'm going to go 0.00, we'll just go 0.001, and then we're going to go to our table. And if you look from the left and the right, there is one value this thing is getting close to as the value of x gets close to 0 from both the left and the right. That value is -4, and we see this value right here. So sine of x over x, this part of the equation is getting close to 1, and then we multiplying that by -4 to get us to a limit as x approaches 0 of -4. This one on the right is a little bit more complicated, but we can still deal with it by using our graphing calculator, so we'll type that in real quick. Keep in mind to use your parentheses correctly. You need to use parentheses when you have 2 or more terms in either the numerator or denominator. In this case, we really don't need one for the denominator. You could put them in there if you wanted to, but not totally necessary. And we're going to see what this thing is doing, and I may not have put the +3 in there. I have to go back, because this is a shift up 3, and for sure I did not do that. So if you happen to enter something in incorrectly in your calculator, if you're an intelligent mathematics student, you will know that your calculator is either lying to you or that you just forgot to type something in. So here's the actual graph of this thing, and we're wondering what is happening as x approaches negative infinity. And it kind of looks like it's evening out here to the left. If we go to our table set, we're going to start at 0, and in this case we're looking at infinity or negative infinity. In this case it's negative infinity. And we're going to do some end behavior or horizontal asymptote investigation. So you want to start at 0 on your table and then make your delta table like 10,000 or something pretty big. And as we go to the left, we can see that this thing is getting close to 3, sort of evening out and getting close to 3. So it appears that this whole setup here is just getting close to 0, and then we're always adding 3. So we could say the limit as x approaches negative infinity is definitely 3. This one on the right, and again keep in mind that these are all in radians. There is no degree symbol, so these are all being radians. And we want to take a look at the limit as x approaches a 0 for this one, and the sine of 0, remember, is for 0 radians, the sine of 0 is the y value, and the y value is 0. So we will get division by 0 with this setup. We can type it in the calculator. We'll just do, let me clear this out, we'll just do cosine of x divided by, in this case we got sine of x. We'll close that up, and we can graph this, kind of get another graphical look and see what's going on. Looks like an interesting function, kind of looks like a cotangent graph. For those of you that remember your identities, the cosine over the sine would be equal to the cotangent. So if we look right here at what's happening from the left as we approach 0 from the left, it looks like this graph is continuing down. And keep in mind that all these other graphs are continuing down, so what you're seeing here is that the graphing calculator, because it's pixelated, it's just the graph is deciding it should probably be close to the y-axis, and it doesn't know what to do. It doesn't know whether to graph it to the left of it or on it or what. So you got to be a better math student and say, well, it looks like this is going to continue down, so there's going to be a vertical asymptote here at x is equal to 0. And as we continue down, we would go down to negative infinity. And from the right-hand side, it looks like we would travel up to positive infinity. So the left and the right-hand side don't agree for this one. So the limit does not exist. Remember that the limit from the left and the right, they have to be the same for the limit to exist.